Lesson 3.6. Prove theorems about perpendicular lines. Let's look at distance from a point to a line. So the distance from a point to a line is the length of the perpendicular segment from the point to the line. Okay, so the following theorem will relate to this idea. So theorem 3.8 states that if two lines intersect from a linear pair of congruent angles, then the lines are said to be perpendicular. So again, if angle 1 is congruent to angle 2, then G is perpendicular to H. Theorem 3.9. If two lines are perpendicular, so line AB is perpendicular to line B, then they intersect to form right angles, 4 right angles. So again, if A is perpendicular to B, then we have angle 1, 2, 3, and 4 being right angles. Theorem 3.10, if two sides of two adjacent acute angles are perpendicular, then the angles are said to be complementary. So angle, let's just put a point here as O. If angle AOB, okay, is adjacent to angle OBC, so the sides are AB and BC, then they share the same adjacent side, and they are perpendicular, so the angles 1 and 2 are considered complementary. So we're going to write this again. Okay, now we're going to use the above theorems to prove the two following examples. In the diagram at the right, angle 1 is congruent to angle 2. Then I can immediately conclude that angle 1 and angle 2 are perpendicular by theorem 3.8. And we want to prove that angle 3 and angle 4 are complementary. So my goal is to state that line QP is perpendicular to line PS, then I can state that 3 and 4 are complementary. So that's my goal here. So I'm going to let angle 1 congruent to angle 2 be my given. And since they're congruent, I can say that line PS is perpendicular to line PQ by theorem 3.8, as I said earlier. And if you don't want to memorize the number here, just write two lines intersect congruent to form congruent angles, and so the lines are perpendicular. If you just write this, I'll know what you mean. So since PS is perpendicular to PQ, we can state that angle 3 and angle 4 are complementary by theorem 3.10, which states that two sides of two adjacent angles are perpendicular, then the angles are complementary. These theorems don't have their own names, so you kind of have to just write out the entire description if you're going to have trouble remember these numbers. Example 2. In the diagram at the right, angle 1 is congruent to angle 2. Okay, and we want to prove that angle QPS and angle 1 are right angles. Okay, so angle 1 and angle 2, since they're congruent, they're given. So that's my first step. And because they're congruent, then angle 1 and angle 2 are going to be perpendicular. So we can state that line PS and line PQ are perpendicular by theorem 3.8 again. So two lines intersect to form congruent angles, so their lines are perpendicular. So this is theorem 3.8. And since line PS and line PQ are perpendicular, then angle QPS will definitely be, and angle 1 will definitely be right angles by theorem 3.9, because if two lines, so PS and PQ here, if these two lines are perpendicular, then these two lines form 4 right angles. The perpendicular transversal theorem states that if a transversal is perpendicular to one of two parallel lines, so if a transversal, for example J, is perpendicular to one of, so the one of will be the line H, two parallel lines here, so H and K are parallel to each other, then it is also perpendicular to the other one, which will be line K. So here's the symbol. If H is parallel to K and J is perpendicular to H, then J would also be perpendicular to K. And now for the next theorem, lines perpendicular to a transversal theorem, it states that in a plane, if two lines are perpendicular, so M and N are perpendicular to the same line P, then they are said to be parallel to each other, okay? So I'm going to write parallel here. And in example 3, determine which lines, if any, must be parallel in the diagram. So we're going to use the two above theorems to help us. So here, line R and line S are both perpendicular to line X. So we have R parallel to S by the theorem lines perpendicular to a transversal. So why don't we just use this as a symbol? Transversal. And then we can also see that line X and line Y are both perpendicular to line R. So by the same theorem, we can say that X is also parallel to Y. And then we can also see that, let me change the color, that at line X and line Z are perpendicular to line S. So line X is also parallel to line Z by the same theorem. And because X is parallel to Y and X is also parallel to Z, by the transitive property of parallel lines, we can say that Y is also parallel to Z. So I'm going to write by the transitive property of parallel lines.